So in last class, what we have done? We have done F1 type generating function. Today we will just go for what? F2 type generating function. And what is this F2 type generating function? So in last class, we have basically summation over Pi Qi dot I minus H is equal to summation over I Pi capital Qi dot minus K plus df upon dt. ये है ना? Or del f upon dt or df upon dt is there. So now let's go for F2 type generating function. So what is this F2 type generating function? So we will just select F as F2 type generating function. And what is this F2 type generating function? Is small qi, capital Pi and T and minus Qi Pi. Now you have to surprise why we are taking this extra term here minus Qi Pi. Now I think this is visible to everyone, है ना?
Yes, sir.
Okay, so we have to just go for minus Qi Pi, and this is due to mathematical compulsion. So and now basically पुनीत आपने जो क्वेश्चन पूछा उसका हम आंसर यहां भी दे सकते हैं, ठीक है?
Yes, sir.
Look at, we are mainly concerned about f actually. Are you getting my point?
Yes, sir.
And this f can be any function. Yes?
Yes, sir.
And what we are going to do, we have just in that particular function, we have deliberately create our favorable function as well as some extra function. And here you can see this f2 is not a function of capital Q, but here we are using this particular capital Qi.
Yes, sir.
Use कर रहा है ना?
Yes,
So
sir.
you can easily use all these things in your calculation. So let's try to go for next level of calculation, and we will just figure it out what will be our relationship of F2 type generating function. Just a minute. Okay, so this is the thing. Let's go for this. So what we have to do, we have to put it into this equation. Then what will happen? This is summation over Pi Qi dot minus H is equal to summation over I Pi capital Qi dot minus F and df upon dt. We have to just go for summation over del F2 upon del Qi, and this is Qi dot plus next will what? Summation over I, and this is also del F2 upon del Pi, and here is Pi dot, and now plus del F2 upon del T minus summation over I Qi dot Pi minus Qi Pi dot. Are you people happy? सही कैलकुलेट किया हो ना?
Yes, sir.
Now the idea is that we actually wanted this thing have to be cancel out. हम यहां पर क्या है, इस चीज को कैंसिल करना चाह रहे हैं. So why deliberately we have taken this one? Why? Because if we are taking F2 type generating function, we have to equate the coefficient of small q dot and capital P dot. आप देख रहे हो F1 टाइप जेनेटिंग फंक्शन में क्या किया था हमने? इसी के डॉट को तो किया था ना, स्मॉल क्यू डॉट एंड कैपिटल क्यू डॉट को इक्वेट किया था. यहां हमें स्मॉल क्यू डॉट एंड कैपिटल Pi डॉट को इक्वेट करना है. So why we have to introduce capital Pi dot in our calculation, And so why we have taken this thing, and you can see this thing is going to cancel out. ये दोनों क्या हो रहा है? Cancel out हो रहा है. And now you can easily equate each and every point. So you can equate qi dot from here. So what you will get? You will get del f2 upon del qi is equal to pi. यही होना भी चाहिए था, because this is your conjugate variable. The second is that del f2 upon del pi, and you can just see del, we are just going to equate the coefficient of pi dot, here is negative sign, so minus qi is equal to 0. So we have del f2 upon del pi is equal to qi. Last but not the least, what we are going to do, we will just take k is equal to h plus del f2 upon del t. Everyone is comfortable?
Yes, sir.
So this is, and f2 type generating function is the one of the very famous generating function. This is one of the most important generating function you can use here. Now we can just solve different type of problems, but you have to always keep in mind that ith is going to equate with ith. So independent variable is going to equate to independent. So qi will generate pi, capital Pi will generate qi, and you can see these both are positive here. है ना? दोनों के दोनों यहाँ पर क्या मिल रहा है? Positive मिल रहा है.
Positive.
है ना? So let's try to go for a one trivial problem. बताओ तो trivial problem क्या हो सकता है f2 का? Most trivial क्या हो सकता है?
Small q, capital P.
Very good. Small q, capital P. This is the most trivial problem for f2. And once we are going for here, then what you will get? Del f2 upon del q is equal to small p. So here you can see capital P is equal to small p. And next you can go for del f2 upon del p is equal to capital Q. That means the small q is equal to capital Q. So virtually what we are doing? The same generalized coordinate is, the coordinate will remain same, the momentum will remain same. So this is some kind of identity transformation, isn't it?
Yes, sir.
What is role of identity? What is role of identity? Identity transformation will always keep your thing same, isn't it? That will always give you. Now, second part we can also do that. If this is my transformation, can we reach to f2 type? Yes, we can reach it. So what is transformation? So we can use this space. So this is my transformation. I just want to go for reverse part of this. So obviously del f2 upon del small q is equal to small p. Is that small p is our favorable variable?
No, sir.
No, this is not our favorable variable. So we have to del f2 upon del q is equal to what?
Capital P.
Capital P. And now we can going to integrate it. When you are going to integrate it, that is qp, and that must be function of what? Small q. Sorry, capital P.
Capital P.
That should be function of capital P. Why? Because small q is variable and we are doing the partial differentiation here. So why this capital P is assumed to be a constant. So whatever be the constant of integration, that will be function of capital P. Everyone is comfortable?
Yes, sir.
Okay. But we have to go for another one also. Del f2 upon del p is equal to capital Q. Is that capital Q is our favorable variable? No, that is not our favorable variable. So we have to go for f2 is equal, sorry, we can just change it. Del f2 upon del p is equal to small q, and we can go for here So F2 is equal to QP plus what you are going to do. Next one is
F2 of
F2 small q.
small
Okay. And now you are going to equate on both sides. You are very lucky that this mixed term is same here. So you can easily equate F1 into this side, F2 into this side. So what I can get, F1 P is equal to 0 and F2 Q is equal to also 0. So your F2 is basically Q and capital P. This is very trivial, very simple.
Sir,
Hmm.
so one question I want to ask, sir, that we have introduced minus capital QIPI just to cancel this capital
Yes,
PI
yes,
QI
yes,
dot.
yes. Actually, what we want this F should be the perfect, this F should be the perfect differential. समझने की कोशिश करो. मैं बार बार आपको यहां थर्मोडायनेमिक्स का ये देता हूं ताकि क्योंकि आप उसको जानते हो, है ना. जैसे व्हाट इज एच, गिव मी डेफिनेशन ऑफ एच. व्हाट इज एच मैथमेटिकली, एच क्या होता है.
So in thermodynamics or
हाँ, yes, in
class
thermodynamics, in enthalpy, I am just talking about enthalpy.
enthalpy.
What is that?
Enthalpy. The U plus TS.
No, U plus PV. I think
Yes,
this
sir.
is.
U plus PV.
है ना? What is F?
Yes.
U minus
Sir.
TS.
Yes, sir.
What is G?
Gives free energy.
What is G? H minus TS.
H minus TS.
Are you getting my point?
Yes, sir.
Why you are using this TS?
So through Maxwell we have derived.
No. You through Maxwell you are not deriving this thing. Actually,
Yes,
from here you are deriving the Maxwell.
Oh.
Are you getting my point?
Yes, sir.
What we want they should behave like a potential.
Yes, sir.
What is meaning of potential? Meaning of potential that they should be perfect differential. So du is the perfect differential, there is not any problem. So u is perfect differential, so du can be equal to 0. You can easily use here. But you have to make h as a perfect differential. So you are just adding PV on the u, then you are getting the h, and where h will be perfect differential. Are you getting my point?
Yes, sir.
So same thing we also want here, that if we are adding it, then this f can be treated as perfect differential. Yes, this is also perfect differential.
Yes, sir.
Okay, so basically they are dependent on a coordinates. Actually, this f are dependent on coordinates. What is meaning of that? That means you can, for the potential, you can easily write in form of coordinates. They are not
Yes.
path dependent, isn't it?
Yes, sir.
So why we wanted this type of situation here, actually.
Okay, sir.
Okay. So let's go for one more non-trivial problem. ठीक है? यहाँ तक clear है?
Sir, can you discuss this point again? The perfect differential.
Perfect differential means you can write this f as a form of df is equal to 0. M dx plus n dy kind of thing. So f can be written as m dx plus n dy. So what will be condition for exact differential? You have del m upon del y is equal to del n upon del x.
Del x.
If this kind of thing is there, then you can go for exact differential. Okay. And if they are path independent, then obviously this df will be equal to 0.
Yes, sir.
Okay. Are you getting my point? इसी
Yes,
का तो
sir.
यूज करके आप पूरा मैक्सवेल डिराइव करते हो. अभी आपके थर्मोडायनेमिक्स शुरू होगी तो आप देख लोगे, है ना?
Yes, sir.
Okay. So basic mathematics is from classical mechanics, and classical mechanics have taken this mathematics from mathematical physics actually. Are you getting my point?
Yes, yes, sir.
So why you are learning exact differential? Okay, that is one part of mathematics. But why you are learning exact differential? So when you are learning exact differential, you are actually using all this thing here in a thermodynamics and all these places. Okay, they are the huge role of exact differential to understand the physical quantity, so or physical system. ठीक है?
Yes, sir.
So always try to connect your mathematical physics to all other topic, mainly classical, quantum and statmat. आप समझ रहे हो मेरी बात? Or even electromagnetic theory also. So these four are fundamentals. So इन चारों को समझने के लिए आपको मैथमेटिकल फिजिक्स का यूज जरूर पता होना चाहिए. Okay, let's try to go for one very fundamental problem. So let us have one Hamiltonian. Let me use this space. This Hamiltonian is very, just you can see, p square by 4q square plus q to the power 4. So this is your Hamiltonian. And what we have F2 type generating function. And what is this F2 type generating function? It's q square capital P. So, do you like this Hamiltonian?
Sir, no.
No, it's a very weird Hamiltonian, isn't it?
Yes, sir.
It is a very weird. Just try to solve the equation of motion, you will get nothing. Now I can remember one question from one student. Again, I have discussed one problem in last class, but last class harmonic oscillator have also solution, and you are also making it very compact. New form of harmonic oscillator at k is equal to omega p. But look at here. Look at which type of system is this? Are you people happy with this Hamiltonian? If someone will give you this Hamiltonian, what you will do with this?
We will not know what it is.
It's a very tough to solve this particular Hamiltonian equation of motion. But now look at what kind of miracle is going to do with this particular F2 type generating function. So what is your F2 type generating function? So if you have F2 type generating function, del F2 upon del Q is equal to what? Small p. So you have 2Q capital P is equal to small p. Isn't it? And second equation is del F2 upon del Q is equal to del F2 upon del P is equal to what? Capital Q. And you can find this F2 is nothing. What will happen? Sorry, this we are going to differentiate it. We will get Q square is equal to capital Q. So Q is nothing but root under Q. Are you happy?
Yes, sir.
And now I can put this Q here. I can get the P. What is my P? My small p is 2 root under Q and capital P. Now put it here. What is your K? K is equal to H plus del F2 upon del T. And you are very lucky that this F2 is not a function of time. So this part is 0. So you have basically P square upon 4Q square plus Q to the power 4. Now put P square here. So when you are putting P square, you are getting 4Q P square by 4. What is your Q square? Q square is Q plus what is q to the power 4? Q square. This 4 and 4 is cancelled. This is cancelled. Now look at, wow. Now, are you happy with this Hamiltonian?
Yes, sir.
Yes, this is harmonic oscillator with mass is equal to 1 and omega is equal to 1. And half can be also neglected, don't worry. Half is just a number. But look at the situation. Now you can easily solve this thing. And once you can easily solve this thing, you can easily write how your Q is going to behave and how your P is going to behave. What will be solution here for the Q? किस तरह का solution होगा?
A sin omega t.
A sin omega t type solution you have. And omega is equal to 1. So you have A sin t type solution. And you have some initial condition, then you can easily, and now you can put here Q as you can put Q square here. And once you will write Q square, and that will be A sin t, and you can easily find Q will be something root under A sin t type solution. Look at, you get the solution in just a fraction of time. If you have a beautiful this type of basically transformation, isn't it?
Yes, sir.
So it is not surprising. It is, and if you want to solve this problem, it will take your whole life that you cannot get the solution correctly. Even if you can use these computers, then also it will create a problem. So now you can see that how strong is the transformation and why there is a need of different type of beautiful transformation known as what? Canonical transformation. Are you getting my point?
Yes.
Look at,
Yes,
we
sir.
converted this ugly equation to the harmonic oscillator. My God. And again, if you are doing this transformation, you can again go for something like omega into p. So every ugly equation which look very ugly, we can convert it into some physical quantity, and yes, we can treat them as finally something like a free particle kind of thing. If we are enough intuitively know what will be the transformation. So look at the symmetry you are getting from each step by step. And how we can use this particular mathematics here. Are people happy?
Yes, sir.
If you have any doubt, you can just raise the
Sir?
question. हाँ बताओ.
K equals to p square plus q square. And why we write omega p, sir?
Because if you want to go for the last class, don't. If you are going for the F1 type transformation from the last class, you can got something like this: omega is equal to 1. So
Yes,
you
sir.
can have also transform K is equal to
K
something
equals
like
to-
P also.
Yeah.
In last class problem, you have something like this type of thing now with half m is equal to 1, put half m is equal to 1 and half m omega square is equal to 1, then you are getting the same thing, isn't it?
Yes, sir. Yes, sir.
So first we have to do some F2 type transformation, and if you are not very satisfied, then again do some transformation, you land at the free particle.
Okay.
Okay. So thing is
Here
that,
omega equals to 1, sir.
oh, why you are just going for the omega is equal to 1? You are just solving this equation, na? Here omega is equal to 1.
Okay.
You are not trying to understand the soul of problem. What is the soul of this whole problem? The soul of problem is that if you can do the proper transformation, you can make a tougher to tougher or some this type of Hamiltonian, you can make it a comfortable Hamiltonian. This is soul of the problem. Omega is equal to 1 is not a soul of a problem. That is part of differential equation. Are you getting my point?
Yes, sir.
So let's go for F3 type generating function. ठीक है? Okay. So I am just giving you one homework for F2 type generating function. So just do it with yourself. Okay. So take this homework and post me. So what is this particular transformation? Q is equal to Q cos alpha minus small p sin alpha, and P is equal to Q sin alpha plus a small p cos alpha. So we have also proved that this is canonically transformed. Proof kiya hai na?
Yes, sir.
Yes. So my question is that find the F2 type generating function if this is your transformation. This is your homework. Just try to solve it. Very interesting problem. Very interesting. Toughest problem, I can also say. This is the one of the toughest problem. Okay. But try to give it solution. Okay. In the booklet, this is given in your worksheet also. Question number 71. Okay. But try to solve it and give me the solution. Let's go for F3 type generating function. Okay.
Yes, sir.
Okay. So again, what we have summation over pi small qi dot minus h, and that value is equal to summation over capital Pi capital Qi dot minus k plus df upon dt. Now we are just going for what? F3 type generating function. So f can be written as F3 type generating function, and this is function of small qi, sorry, that will be function of capital Qi small pi and t. Now should I go for some plus or minus? Should I go for some plus or minus? Anyone?
No, sir.
No. So if it is qi dot pi dot, so which thing you are going to compare?
Coefficient of qi dot and small pi dot.
Very good. Coefficient of capital Qi dot and small pi dot. So capital Qi dot is here. So are you happy with this?
Yes.
But
Yes, sir.
is that anything which is small pi dot?
No,
Yes,
sir.
it is.
No. No. Are you getting my point? So you have to add or subtract something. So you are going to add it something or going to subtract something?
Sir, add it.
Hmm?
Sir,
Add it. Add. Why?
Then
Because you want
multiply.
to cancel this particular term, isn't it?
Yes, sir.
Yes. Very good. Excellent. Very good. So this will be pi qi will be the thing. Okay. Now you can easily use this thing and you can finally get the answer. So should I write the direct relation?
Yes, sir.
Anna, you can just do it with yourself. So del f3 upon del qi is equal to minus pi and del f3 upon del small pi क्या होगा बताओ?
The QI
qi, but that will be also
minus
minus
Minus.
qi. Okay, so आप हमेशा याद रखोगे F2 में दोनों क्या होता है? प्लस,
positive
F3 में दोनों क्या होगा? माइनस. Okay,
minus.
and last but not the least, k is equal to h plus del F3 upon del T. Okay, so let's try to go for one very nice problem of this F3 type generating function. Okay, so once you will do this problem, that will also help you to solve your homework for F2 type generating function. Are you getting my point? So
Yes,
let's
sir.
try to go for it. ठीक है, आगे बढ़े.
Yes, sir.
चलो. So let me collect the question first because it's a little bit lengthy one. Okay. So this is Goldstein unsolved problem. Okay. So this is capital Q is equal to log 1 plus Q to the power half cos P, and capital P is equal to 2 1 plus Q to the power half cos P and Q to the power half sin P. What you have to do, you have to just prove F3 type generating function is minus e to the power q minus 1 square tan P. Prove that. Okay. So this is the very important problem, Hannah. And why it is important? Because it will just give you all the thing that you have learned earlier, that all the mathematics you have to use in this particular problem. So should we go for this one?
Yes, sir.
है ना? एक बार problem देख लूं. So just एक बार देख लो. Capital Q is equal to log 1 plus Q to the power half cos P, and capital P is equal to 2 into 1 plus Q to the power half cos P bracket Q to the power half sin P. Is that correct? Written in board? Okay.
Yes, sir.
Chalo. So let's start to doing this particular problem. शुरू करते हैं. Okay. So what is first thing we have to do? Del F3 upon. By the way, what is F3? F3 will function of capital Q, small p, and maybe function of time. Isn't it?
Yes, sir.
Okay. So we have to go for del F3 upon del Q is equal to what? Minus P. This is my first equation. And second equation is del F3 upon del small p is equal to minus Q. Yes? Now, just tell me, this capital P is your favorable variable or not?
No.
No.
No, sir.
So you have to change this capital P as a function of a small p and capital Q. Isn't it?
Yes, sir.
Okay. Now look at here. this capital P can be written as 2 time, just a minute, एक और गड़बड़ है शायद. Okay, ठीक है. Okay, so this capital P can be written time 2 time e to the power q from here. लिख सकते क्या इस पूरे टर्म को?
Yes, sir.
लिख सकते हैं ना?
Yes, sir.
Yes,
Okay, so just look at, we are writing 2 time e to the power capital Q, and this q to the power half can be written from here. Yes or no? So this will be e to the power q minus 1 by cos p. And sin p. Is that small p is favorable variable? Yes, small
Yes, sir.
p is favorable variable. So are you people happy or not?
Yes, sir.
We have just transformed each and everything as a capital Q and a small p. हम लोगों ने इसे ट्रांसफॉर्म कर दिया है कैपिटल Q और स्मॉल p के टर्म में. Now look at what is going to happen. So we have del F3 upon del Q is equal to minus 2 tan p is there, and we have e to the power 2q minus e to the power q. So we have to just go and differentiate it, sorry, integrate it. So when we are going to integrate it, then what we will get? F3 is equal to minus 2 tan p, and this is nothing, e to the power 2q by 2 minus e to the power q plus constant of integration. What will be constant of integration?
Some function of
f of small p.
F of small p, and you can put it f1 or f you can also write. So this is my f3. Now we have to go for this one also. So I can get this one from here easily from first equation.
Yes, sir.
Sorry, and yes, negative sign will be there. Good.
Sir, f of small p.
What?
Sir, the last term f of small p.
Yes. So what will happen?
Sir, f of capital P.
This is function of a small p. Why capital P is there? F3 is function of what?
Small p.
Small p. So if you are going to take the again in last class I have told this thing. Just say del F3 upon del Q means what? Differentiating F3 with respect to capital Q
Capital P.
by keeping a small p as a constant.
Yes, sir.
Are you getting this thing?
Yes, sir.
Are you the same student who is asking this thing in the last class also?
No, sir.
No. Okay. So always keep in mind. Okay. Only the variables are either capital Q or a small p. So constant will be either capital Q or a small p. Okay.
Yes, sir.
Okay. So what will be del F3 upon del P is equal to minus Q. What will be minus Q? E to the power Q minus 1 square sec square P. Yes?
Yes, sir.
Just check it. Just check it. Am I correct or not? Yes. So what you will get? You will finally get, you're just going to integrate it. You are going to integrate with respect to what?
Small p.
Small p. So what will be constant? Capital Q.
Capital.
So from here, you have F3 as minus e to the power Q minus 1 whole square. And when you are going to integrate it, that value is 10p plus F2 capital Q. Are you people happy?
Yes, sir.
Now, the next challenge is that now you cannot equate this thing directly. अब यहाँ पर आप directly equate नहीं कर सकते. This is not a trivial problem. This is a typical non-trivial problem. Are you getting my point?
Yes, sir.
Yes, sir.
So what will happen? You have to see the mixed term. What is mixed term here? This one and this one is mixed term, isn't it?
Yes, sir.
So you have to do some manipulation such that this mixed term can be equal in both sides. So here I am just going to make the manipulation into this. What I am going to do? Minus 2 tan p, I can write e to the power 2q minus 2e to the power q. So I can add plus 1 and I can subtract plus 1, and by 2 is there and plus f1p is there. Can I do this thing? So this 2 and this 2 will be cancel out, and I can write this thing is tan p, and this value is equal to e to the power q minus 1 whole square, this whole thing, and this is going to be clubbed with this one. So what will happen? Plus tan p plus f1p. Are you getting my point? Can I write whole this thing like this?
Yes, sir.
And what you will do, you can now equate this and this are same, and you can equate this thing on both sides. So now, if we are going to equate this thing on both sides, what you will get? So I can get here f1p plus tan p, only function of p in this side, is equal to 0. In here, there is not any function of only p, isn't it? And from here, you can go f2q is equal to 0. So what is your f1p? Is nothing but minus tan p. So you can find that it is not always trivial that all your constant of integration will be same. Can you see this problem? Wonderful problem, unsolved problem from Goldstein. So now you can attempt your last question, that will be homework. That is something like this, where you will get f1 also, you will get f2 also, and that will be not 0. I think that kind of thing is there. Very simple calculation, but yes, you have to keep focus on the concept. The concept must be very much crystal clear. Okay. So now, last but not the least, let's go for what? F4 type generating function. Are people okay?
Yes, sir.
Okay. So again we have summation over pi qi dot minus h is equal to summation over capital Pi capital Qi dot minus k plus df upon dt. And what is my f? Now my f is f4 type generating function. क्या बचा जरा बताइए?
Small p, capital P.
Small p.
Very good. Small p, capital P, and it may be function of time. So बताओ कुछ ऐड करें कुछ सब्ट्रैक्ट करें?
QI dot है left side में.
क्या करें? ऐड क्या करें बताओ?
QI dot.
स्मॉल या कैपिटल?
Small.
स्मॉल. QI PI. और सब्ट्रैक्ट क्या करें?
Capital.
माइनस कैपिटल QI and pi. Okay.
Yes,
So
sir.
this will be just generate your F4 type generating function. Okay. So I am just giving you the final one. So you can just do this thing with yourself. So I think you will get del F4 upon del P or Pi is equal to minus Qi, and del F4 upon del capital Pi is equal to capital Qi, and finally you will get K is nothing but H plus del F4 upon del T. Are you people happy?
Yes, sir.
Okay. So you can just use this thing. F4 type generating function is very rarely used, but most important is F2 type generating function. The thing is that how you will remember the thing, है ना? कैसे remember करोगे? This is the final thing. So you can have F1. किसका किसका function होगा?
Small q, capital Q.
Very good. Small q, capital Q, T. Now, what will be F2?
Small q.
Small q, capital P, T. What will be F3?
Small p,
Small
capital
p,
Q,
capital
T.
P,
Small p, capital Q,
capital
P.
T. यही है ना?
Yes, sir.
And what about F4?
Small p, capital P.
Small p, capital P, T. Now, अब आपको मेन थिंग तो पता चल गया है कि स्मॉल क्यू क्या देगा? स्मॉल पी देगा, है ना? del
Yes, sir.
F1 upon del Q will always give you small p, है ना? Del F1 upon del capital Q always give you capital P. Conjugate variable. Are you people happy?
Yes, sir.
सेकंड वाले को भी देख लेते हैं. Del F2 upon del Q always give you small p. Del F2 upon del P always give you capital Q. ठीक है?
Yes, sir.
इसको तो याद रखने की जरूरत नहीं है ना, ओनली ये याद है तो बाकी आप अपने आप लिख लोगे, है ना? del F3 अपॉन del P क्या देगा? स्मॉल q. del F3 upon del Q is capital P. Now del F4 upon del small p Q del F4 del capital P is Q. Now you can remember that F2 is always both positive, F3 is both negative. ये तो याद रहेगा?
Yes, sir.
Yes या no? F2 will be positive, F3 will be negative. दोनों का F3 नेगेटिव रहेगा. Now F1 में क्या है? कैपिटल वाला नेगेटिव है. एक सिर्फ याद रखो, F1 में कौन सा है? कैपिटल वाला नेगेटिव है. यस या नो?
Yes, sir.
यस. F4 में क्या होगा? स्मॉल वाला नेगेटिव होगा. दैट्स इट. यू कैन रिमेंबर ऑल दिस थिंग. ठीक है ना? ठीक है? सो F2 इज बोथ पॉजिटिव, F3 इज बोथ नेगेटिव. एक को याद रखो, दूसरा अपने आप आपको याद रहेगा. ठीक है? और जरूरी नहीं है कि एग्जाम में आपको ये कहे कि F2 टाइप निकालो, F3 टाइप निकालो. अगर आपको ये कह दे कि F स्मॉल q P एंड T निकालना है, तो कौन सा निकालना है?
Second.
F2 टाइप निकालना है. आर यू गेटिंग माय पॉइंट?
Yes, sir.
ठीक है? तो आप यहीं से आप आइडेंटिफाई करोगे किस तरह का जनरेटिंग फंक्शन है. सो यू कैन सी. सो ये सारी चीजें हम बहुत ही ज्यादा जगह पर यूज करते हैं. एक बहुत ही फंडामेंटल है मैक्सवेल रिलेशन, जिसका कि मेन फंडामेंटल यहीं से आता है. कॉन्जुगेट वेरिएबल्स. You can see, I am just giving you the final thing of what is meaning of Maxwell relation and how you can get it. And all these four Maxwell relation can be derived from four different type of potential, isn't it? So you have basically two type of conjugate variable. Look at what is the role of Maxwell relation and why you are using it. This is very important. So we have a one variable is pressure and volume and another is temperature and entropy. By the way, this pressure is intrinsic quantity or extrinsic quantity? Temperature is intrinsic or extrinsic?
Intrinsic.
Intrinsic. This is intrinsic. This is intrinsic. This is extrinsic. This is extrinsic. P into V will give you always the dimension of energy. S into T will always give you dimension of energy. The real challenge is, you can see, you can easily connect pressure, volume and temperature from the equation of state. कहां से मिल सकता है ये? Equation of state से. And don't worry, we have direct relationship with pressure and volume with the Boyle's law. We have direct relationship between temperature and volume for the Charles law. For the, if I am talking about the ideal gas, even you can for the another gases also you have equation of state between the relationship between pressure, volume and temperature. Now the relationship between entropy and temperature is direct variable because they are conjugate variable. So what is the real challenge? The real challenge is how you are going to calculate del S upon del V at the constant temperature. How you are going to calculate del S upon del P at the constant temperature, or vice versa, del V upon del S at the constant pressure, del P upon del S at the constant volume. Are you getting my point? This is one of the biggest challenge. You have a thermometer and you have for temperature, volume, pressure, different type of equipment. You can measure it easily into the lab with some law governing by this. But how volume and entropy, volume and pressure is going to interrelated, it is very difficult. So here Maxwell came into picture. From this world, he just connect this particular world. This is two conjugate variable. This is two conjugate variable. He connected all this thing. Now you can see what is going to happen. Del P upon del T. It is very easily calculated with the equation of a state, isn't it?
Yes, sir.
Del V upon del S.
Del T by del P.
Del T upon del P. It is easily calculated with the equation of a state. Now, what will be here? Minus del V upon del T with the constant pressure. Minus del T upon del V at the
Constant entropy.
constant entropy. This is constant entropy. Now, this thing you can see. Here you cannot use equation of state. 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 But here you can easily use equation of state. Here you can easily use equation of state. Here you can easily use equation of state. And all four variables are actually derived from four type of potential. You can just search which one is going to derive with the U, which one is going to derive with the H, which one is going to derive with the F, and which one is going to derive with the H. Obviously, I don't remember which one is going to derive with which one, but yes, you can easily connect all these four relations with all different four type of potential. And that all four potential have exactly behavior of your basically generating for this 4 type of generating function. U will be function of S and V. H will be function of S and P. F will be function of, batao, T and V. And G will be function of T and P. Now you can see. One is from this world and another is from this world. Is that hai ki nahi?
Yes, sir.
So today go and learn this Maxwell relation. And from this point of view, you can see this is P and this is Q, this is P and small q1, this is small q1, this is small p1, small q1, small and capital Q1, capital P1, and you are just connecting these two things. Something like this. We are just doing it in a generalized coordinate, but in a thermodynamics, what is your state? Pressure, volume, temperature, and entropy. You have pressure and volume, and then you have entropy and temperature. You can convert from here to here, and you can convert from here to here. And this 4 Maxwell relation will make your life easy because you can use equation of state to finding this particular thing. Are you people happy?
Yes, sir. Sir.
बताओ.
Sir, this Maxwell relation, इसका mention है क्या Goldstein book में?
Yes, it is.
Like
It is discussed actually, little bit.
Okay, okay, sir.
I will just
Okay,
give you the which page you have to read. I will give you.
Okay, sir.
Okay.
Yes, sir.
Little bit hai. I will just search and then I will give you. ठीक है?
Okay, sir.
ओके. थोड़ा बहुत है, बट मैंने इसको काफी ज्यादा खोल करके आपको बता दिया है बेसिकली. ओके. So conjugate variables are very, very important thing. Are you getting my point?
Yes, sir.
This is very, very important thing. Okay, so we have finished a very important topic, and now it's your turn to complete it with a test. ठीक है?
Yes, sir.
Sir.
Please test जरूर दीजिए.